In this video, we're going to learn how to apply the laws of definite and multiple proportions. So if we look at this data table here, this is the data for 4 samples containing copper and sulfur being heated and separating their copper and sulfur and seeing what masses there are. So in sample A, we started off with 60.48 grams of this substance containing copper and sulfur, and we ended up getting 49.06 grams of copper and 11.42 grams of sulfur. So as we're answering this question, which 2 samples are the same, what we need to do is first take, for all these samples, take the ratio of the masses of copper to sulfur. And to do that, you'll take the mass of copper and divide it by the mass of sulfur. So for A, it's 49.06 grams divided by 11.42 grams. And what we get is 4.30 grams of copper to every 1 gram of sulfur is what that means. In the case of sample B, we do the same thing, but we get 2.15 to 1. In the case of sample C, we get 3.47 to 1. And in the case of sample D, we get 4.30 to 1. So as I look at these 4 ratios, A and D have the same ratio, which indicates through the law of definite proportions that they are the same compound. They have different masses. They have different masses of each component, but those components combine in the same ratio, and that indicates that they are the same compound. So the next question, if the formula for sample B is CuS, what is the formula of sample A? Well, I look at 4.30 and I can divide that by 2.15 and I get a perfect 2-to-1 ratio. Now, that 4.30 is the mass of copper per sulfur in compound A. And the 2.15 is the mass of copper per sulfur in compound B. So by dividing these ratios, I get the ratio of the ratio, which is 2. This means there is twice as much copper per sulfur in compound A as there is in compound B. So if compound B is CuS, then compound A needs to have twice as much copper per sulfur. If we keep the sulfurs the same, the copper is just going to be twice as much. So we have Cu2S. So it's Cu2S. I have 2 coppers and 1 sulfur in sample B. In sample A. In sample B, I have just 1 copper and 1 sulfur. And remember that samples A and D are the same. So samples A and D are both Cu2S. Sample B is CuS. Next question, which sample is a mixture of copper and sulfur? That's going to be C. And C is a mixture of copper and sulfur because it doesn't abide by, well, any of the mass laws. So the ratio of components is not the same as either of these. And if you were to take the 3.47 over the 4.30, or the other way around, the reciprocal, if you were to try to take the ratio of 3.47 to 2.15 or 2.15 to 3.47, you wouldn't get a simple whole number the way that we did here. Here, we were able to apply the law of multiple proportions. But in the case of compound C, actually it's not a compound, it's a mixture of copper and sulfur, because with a mixture, you can have any ratio of 2 components. In a compound, you always need to keep certain mass ratios. Last question is, in a sample of CuS with a mass of 25.0 grams, what would be the mass of Cu? This would be applying the law of definite proportions again. And we can treat this like dimensional analysis. You can also set it up, since we are talking about definite proportions, we can look at it like a proportion too. And I'll show you kind of both ways. So we know that we're looking for the mass of Cu. So we can say X grams of Cu. And those X grams of Cu are in a 25.0 gram sample of CuS. And we're saying that that is equal to a known amount of copper in a known amount of copper sulfide, CuS. Well, what we can do is we can go back to sample B. We know that in sample B, there's 13.65 grams of copper in a 20.00 gram sample of copper sulfide. Now, if we simplify this, what we'll end up doing is multiplying both sides by 25.0 grams of copper sulfide. So this really is dimensional analysis at this point. It's just that the dimensional analysis would skip the part about showing the proportion. But notice our grams of copper sulfide, they cancel out, and we would need to multiply the 13.65 times 25 divided by 20. So that would sorry, these end up canceling out. Sorry, the stylus is not working very well right now. But notice that this essentially becomes dimensional analysis because we have 25.0 grams of CuS times 13.65 grams of Cu over 20.00 grams of CuS. That proportion right here, again, is just the known proportion of copper to the compound containing copper in sample B. And with that, we can get to our X grams of copper. What we would find out is that X is equal to 17.06 grams of copper. And that's all. Hope this video has been helpful. Please leave any feedback you have in the comment section below. Thank you.